Hi, everyone, and welcome to the Mr. X free class on Euclidean geometry. Our particular concern today is we are dealing with theorems done in grade 11, but also examinable in grade 12 as well. So please make sure that as we go through the lesson, you are very aware of what we are doing today. We did part one, I think, of this when we did just the basic theorems and basic questions. But this time we're doing past exam papers that are more interesting. But before all of that, I've got more exciting news for everyone because I am doing massive June revision classes for both mathematics and physical sciences, touching all grades, grade 11 and grade 12. So here are the dates and the times of it. Notice that each session is 5 hours long. And for each session, it's going to be 100 rands only. So booking will be open from Wednesday, this particular Wednesday, but you can also be able to book even after Wednesday. But then the idea is that it's going to be a 5-hour lesson for each session, covering all the topics that you guys are going to be doing for your June exams, massive things that we're doing, past exam papers. I've got a whole beautiful thing lined up for you. Very cheap, if you ask me. That's 5 hours online for 100 rands. That translates to only 20 rand per hour, which is a lot of nothing, if you ask me, in the South African economy. So cheap, but quality. That's what I will be doing. Talk to your parents, tell them and let them know that there is going to be a mathematics and physical sciences June revision classes with Mr. X. I'll post this also on my groups so that everyone can be aware of what is happening in the dates and the times. Then secondly and lastly, we have what I call my normal online classes, which take place every single week. Monday, that's grade 12 maths. Tuesday, grade 11 maths. Wednesday, grade 12 physical science. And Thursday, grade 11 physical sciences. These lessons start from 7 p.m. to 9 p.m. On those particular days, we concentrate on the topics that you're doing at school. We run through them again, do past exam papers, reinforce and consolidate the information that is very important and needed. So for the month of May and June, this is the particular schedule for both mathematics and physical science. Already this particular week, we're getting to week 2. For an example, tomorrow between 7 and 9, we're doing sketching of cubic graphs for grade 12, that's maths. Then on Tuesday, we're doing functions part 1, that's for grade 11 mathematics. Again, this week on Wednesday for physical science, rates of reaction part 1, very challenging topic if you ask me. Meta and materials part 2, that's grade 11. So this schedule we follow throughout the whole month. And these lessons are 50 rand for every single lesson. So if you want to do the whole month, there's 5 lessons for maths, 250, 5 lessons for physics, 250, both of them 500 rands if you want to come through. So they are also recorded, and all the videos for all the previous lessons and even these ones that I'm going to be doing in the month of May are available. All right. That's the basic intro. Let's get down to the business of the day. Let's do this. We are dealing with Euclidean geometry. Let's begin. Write down the title right there because it's very important as we go through that we understand where we took these questions from. So write down the title right there, 2016 Eastern Cape Prelim. That's paper 2 and question number 9. I'll run through a couple of questions, maybe about 8 or so questions or 7 or 8 questions. Then I'll give you stuff to try on your own and we keep talking and engaging together. It's important to read, to understand, to work, to pull through. Here we go. I begin. In the diagram below, A, B, C, D is a cyclic quad. So these are keywords, A, B, C, D. So there's my A, there's my B, there's my C, and there's my D. So A, B, C, D is a cyclic quad. I want you to remember that a cyclic quad is a four-sided shape where its points are on the circumference. So keep that in mind. The points of a cyclic quad are all on the circumference. C on the circumference, B on the circumference, A on the circumference, D on the circumference. RPB, the question goes on, is a tangent. So there's RBP is a tangent to the circle, and my center is O. Keywords to remember. Now, if the center is O, then the following applies. It would mean, therefore, that the line OB, this line OB becomes a radius, because radius is any line drawn from the center of the circle to the circumference. OD also is radius. Our first question, 9.1, says the following. Determine the size of the following angles. They want O1. So they want this angle, O1. We don't know it. We notice that B4 is 30. So B4 is 30. That's what we notice, and we are given that. So B4 is 30. My reason is that I'm given. But I'm looking for O1. Check this out. The angle D3, there's D3 here. The angle D3 is also equal to 30, and your reason is angles opposite equal sides. So when you write the shortcut, you say angles opposite equal sides. Now, I noticed that some of you would think that, or would want to write that it's an isosceles triangle. That's very true, but they do not want you to use that as a reason. They want you to say D3 is equal to B4 because its angles opposite equal sides or equal radii. Remember, this is radius and the other one is radius. So they are angles opposite equal sides. Then now I'm looking for O1. Notice D3, which is 30, plus B4, which is 30, plus O1, when added together, they must give you 180. Your reason being angles that are in a triangle. So angles in a triangle, or you can say sum of angles in a triangle. The rest is math. 30 plus 30, that's 60. 60 to the other side. O1 eventually is 120. Very quickly, right there. So let's pull through from there. So you can say angles opposite equal sides for this, or you can say angles opposite equal radii. Don't say radiuses. There's nothing like that, Chuck Norris. Okay? When it's more than one radius, it's radii. Radii. Don't say radiuses. 9.1 done. 9.2 quickly. So we start with very basic questions using the theorems that we learned in grade 11. They want A. That's what they want right now. Let me go for A right there. I'm ready to start for A. Let's go. Now, I noticed something. I was told that there is a cyclic quad. So I am looking for the ideas behind. If that's a cyclic quad, that means A plus C would be equal to 180. I want you to remember that. It will help us on 9.3. But notice A is made by a line from D and a line from B. In maths, we say they are subtended. So the line DB subtends A at the circumference, the line DB. Then the line DB also subtends O1 at the center. Line DB subtends O1 at the center. I think you see what I'm going to say. It means angle A would be equal to 60 degrees. Remember, O1 is 120. Angle at center, your reason, angle at center right there is twice the angle at circumference. You are allowed to write it in this shorthand. This is the shorthand that is ultimately allowed right there. Okay, perfect. So A is 60. I must stress that there are so many ways of doing these questions. So I'm not going to run through all the various methods available. I'm just going to pick out one method or so. You may be able during the course of the lesson to see other methods that we can ultimately use. 9.2, done. Let's go to 9.3 very quickly. 9.3. Remember, the angle at the center is the big one. So the one at the center is big, 120. The one at the circumference will be half of the one at the center. Angle at center is twice the angle at the circumference right there. So I'm good to go. Just one more time, remember the angle A is subtended, made by a line from D, this line here, and a line from B. So we say DB. DB subtends A, DB subtends O1, DB subtends A at the circumference and O1 at the center. I'm ready for the next one. Here we go. Going. Now, the next one is all about finding C. I gave an idea that there is a cyclic chord, so it would mean that the opposite angles of a cyclic chord are supplementary. That means A plus C should be equal to 180. Your reason, opposite angles of a cyclic chord. They are supplementary. The word supplementary means that they add up to 180. A is already 60. We calculated. I'm looking for C, and you do your maths properly right there. The value of C becomes 120. That's all good and well. I am right there. Perfect. C is 120. We start small. Then the next question says ADB. I must emphasize, fam, that without understanding the theorems, it's going to be very difficult to understand the questions. The questions come with theorems, all right? All the questions come with theorems. So it's very important that you know that a certain question would have maybe even more than one theorem in it, just like what we are doing here. I'm ready for the next one. Taking this out, gone. ADB. I want to follow what they're talking about. ADB. So this is A, okay, D, okay, that's B. So ADB, I think the whole of D3 and 4, that's what they want. Notice that there is B6. B6 is an angle drawn from the tangent until it touches the chord AB. Again, there is B6. B6, who are you? I am an angle drawn from the tangent and I'm touching the chord AB. The chord AB subtends D3 and D4. The chord AB subtends D3 and D4 at the circumference. In other words, I'm saying the chord AB makes the angle D3, D4 at the circumference, which is just ADB. So there's a theorem that uses that concept. The theorem says an angle drawn from the tangent of a circle to the chord is equal to the angle subtended by the same chord in the alternate segment. As a shortcut, that's Tangent-chord theorem as a shortcut. So at the end of the day, ADB is 70 degrees. Your reason is Tangent-chord theorem. That's your reason for that one there on 9.4. First one done. I need some questions, but I think people are already answering some of the stuff that we have on the chart. So we're good to go. Let me quickly go to my next one. I start with basics, but I want to increase the tempo and we work together on that one. Again, please note the important theorems. Look at them, look for them in a typical question so that you can be able to understand. The Tangent-chord theorem, which is one of the most important theorems, says that if there's an angle drawn from the tangent, RPB is a tangent, they told me, drawn from the tangent, and it touches the chord. Which chord does it touch? AB. The question to ask is, AB, who do you subtend at the circumference? AB subtends D3 and D4, which is just ADB. Again, angle drawn from the tangent touches the chord. I see that. The chord, who do you subtend at the circumference? I subtend D4, D3, so 70 degrees becomes equal to that. When you're writing this theorem, you say an angle drawn from the tangent, follow my thinking, from the tangent of the circle to the chord of the circle is equal to the angle subtended by that chord, OAB, in the alternate segment. So that's your Tangent-chord theorem. Perfect. I've repeated as asked. I want to go to my next one. You'll see it coming again in many different questions. Next question, please. Let's keep going together. Here's a 2018 Gauteng Prelim Paper 2, question 8. I'd like you to write this one down. Write down the title. We will work together. And again, there will be Tangent-chord, just in case people do not understand it or are trying to learn it via questions. I'm ready for 2018 Gauteng Prelim, and it's paper 2, and it's going to be question right there, 8. The story starts as follows. In the diagram below, TAP is a tangent to the circle ABCDE. I see it on the diagram as well. About A, B, C, D, and E. Then it says AE is parallel to BC. It's also on the diagram. So that's AE parallel to BC, and DC, so there's my DC, is equal to DE. So that means triangle DEC is an isosceles triangle because there's 2 sides in it that are equal. So they told me DC is equal to DE. So the triangle DEC is isosceles. Then they say TAE is 40, which I see here, and AEB is 60, which I see there. First question is quite straightforward. 8.1, identify two cyclic quadrilaterals. Identify two cyclic quadrilaterals. So they want you to write them in terms of letters. Let me see what I have. Remember, I said in the previous question that a cyclic quad is a four-sided shape where all the points are on the circumference. Four-sided shape where all the points are on the circumference. So let's see if we can identify a cyclic quad in this case. I think I see E, A, B, C. Let me see if it's correct. So there's E, all right. A, okay. B, all right. C. That's definitely my first one. I think I see another one. There should be two of them. I think I see E, B, C, D. So there should be another one, which is E, then B, then C, then D. So that should sum up my two cyclic quads there. Now, the arrangement of the letters doesn't really matter, okay? As long as all the letters come through. I see someone wrote A, B, C, E. I agree. Then B, C, D, E. I also agree. As long as all the letters appear, we are good to go. 8.2. 8.2. Determine with reasons the size of the following angles. Determine with reasons the size of the following angles. B2. So there's B2 right here. I have a question for you, fam. Which lines subtend B2? Who makes B2? B2 is made by who? You tell me. Which line subtends B2? Right there. Talk to me now. Let's hear what the people are saying. Talk to me. All right, somebody says AE, completely agree. So AE subtends B2. In other words, we're saying to ourselves, a line from A and a line from E is making B2. And then we're looking for B2. The angle 40 is drawn from the tangent and touches the chord AE. Who does AE subtend? B2. What can we say now? B2 is equal to 40 degrees. Your reason, Tangent-chord theorem. We're ready for Tangent-chord. Thank you so much for your answers. You're doing well. I'm happy about that. 8.22 right there. 8.21 rather. Then let's go for 8.22. I'm looking for B1. You let me know where there's a struggle. So with the 40 degrees, you just look at the tangent. Then you say, when a tangent, who do you touch? I touch AE. AE, who do you make it the circumference? B2. So B2 is 40. Tangent-chord theorem. I'm ready for B1. I see people are already trying to answer that. I think B1 should be 60 degrees. Why? Alternate angles. So B1 is 60 degrees. It's alternate angles right there, as can be seen. All right, that's B1. But remember, when you say alternate angles, you must be able to state which lines are parallel. So AE parallel to BC. Please keep in mind, fam, you can't just say there's alternate angles unless there's parallel lines, okay? So the condition must be there should be parallel lines. Then we can start talking about alternate angles. D, I'm ready for 8.23. D now, ready for 8.23 right there. I think I see a cyclic quad, I did mention it, and I think it's going to help me to find my D. Follow my lead. So this cyclic quad, I think we also wrote it to say we know something about it. So what does it mean, say? It means B1 and D, when added together, should give you 180 y opposite angles of a cyclic quad. So opposite angles, I'll just write CQ, but guys in the exam, just write cyclic quad. B1 is 60, the rest is maths. D, I think D would be 120. That's my D right there. We're good. I'm ready for 8.24. Talk to me where there's a problem. I want E1. E1. All right, you guys are doing well. E1. Okay, what's happening? What's happening? Now, I noticed something. We already know that D is 120. Perfect. E1 is equal to C1. Your reason is opposite, or rather angles, opposite equal sides. So it's angles that are opposite equal sides. That's what it is. So E1, okay, plus C1 plus D, which is 120, is 180 because of sum of angles in a triangle. Okay, that's all good and well. Then further on, notice the following. Notice that we said E1 is C1. So instead of putting the C1, I can put it as E1 again. So it becomes E1 plus E1, which is 2E1, then 120 to the other side. That gives me 60. You guys are correct. E1 is 30. 30 right there. That's E1 is 30. Right, very important. Okay, beautiful. So it's always important when you're doing these questions to be able to notice if there's a cyclic quad, like what I did here and said the opposite angles of a cyclic quad, B1 and D, when added together, will give you 180. Opposite angles of a cyclic quad are supplementary. Then for the last one, we agreed that DEC is an isosceles triangle. So E1 and C1, the base angles are equal. But when you're writing your reason, you say angles opposite equal sides. So E1, C1 are equal. So E1 plus C1 plus 120, which is D, is 180 angles in a triangle. But who is C1? He is E1. So instead of writing C1, you can put E1 again. So E1 this plus E1 there, 2E1, 120 to the other side, 60. Divide by 230. I'm good. I want my next question. Talk to me as we're going along. Also, I encourage us to interact on the chat and help each other out throughout the whole lesson. I'm ready for the next one. It's continuing from from the previous one. Right? It's continuing from the previous one. Let's keep working on it. In the diagram below, the radius CO is produced to bisect chord AB at D. The word bisect means to cut into two equal parts. So this whole chord CD, it's not a diameter. It doesn't go to the circumference. This whole chord is bisecting AB at D. So when it's bisecting AB at D, it means D is a midpoint. That's what it means. It means D is a midpoint. So it means the line AD and the line DB are equal. So I want to write that as a statement because it's going to help me out. So let me hear this out. So D is midpoint. Why do you say that, say? Because CD bisects AB. So D, who are you? I am a midpoint. Fine. CA is 34. I think it's on the diagram. Then the wall of AB is 40. It would mean then, if AB is 40, that AD is equal to DB because B is midpoint, and they will all be equal to 20 millimeters. That's what it means. Since the wall of AB, that wall line AB is equal to 40, it means AD is 20. I need to D is a midpoint, and DB is also 20. The question then says, please calculate the size of C. So it means size of C. So this angle C, I don't know it at all. Want me to calculate the size of C. Perfect. There's something else that I can learn from here. Theorem number 1 in grade 11 says that a line drawn from the center of the circle to the midpoint of the chord is perpendicular to the chord. So the angle at D is 90 because why? Line from center to midpoint of chord. That's theorem from grade 11. A line drawn from the center of the circle is perpendicular, from the center of the circle to the midpoint is perpendicular to the chord. I'm looking for C. What can I do? Let me see what I have. You can use trigonometry here, actually. You can be very clever and use trig ratios. Look at it. The side, let me use a different arrow. The side AD is the opposite side. And the side AC, so this one will be the opposite side, right? And the side here, AC, would be the hypotenuse side, if I'm not mistaken. And then the side DC should be the adjacent side. Talk to me, work with me. What am I looking for? I'm looking for C. I'm looking for C. So what do I have? I've got the opposite side, 20. I've got the hypotenuse side, 34. Trig. Sine C is opposite, 20, over hypotenuse, 34. Then I'm looking for C trigonometry trig equations. Shift of sine of 20 over 34. In this case, at the end of the day, it means the angle C, if you do it to 2 decimal places, you should get 36,03. Clever way of thinking. If you go back to trigonometry, fam, you should remember that trig ratios are applicable if your triangle is right-angled. Trig ratios are applicable if your triangle is right-angled right there. So that becomes your answer, C, right there. How did I get 20? They said AB is 40 millimeters. They said the line CD bisects AB, so D is a midpoint. If from here to here is 40, then halfway through AD should be 20. Love what the people are doing, helping each other out. Let's keep going so we can cover quite a lot of things together. Write it down for those that haven't. I'm giving you 10 seconds to do it. Then I move on to something else. Let's keep working. I want to increase the tempo a bit so that it becomes easier to understand. No, D is not an angle in the semicircle. AC is not a diameter. It's not a diameter right there. Sine is opposite. Yes, the opposite is 20. The hypotenuse is 34. Opposite over sine C. Sine C. C. Opposite over hypotenuse right there. All right, I'm taking this out. It's gone, gone, gone. SOHCAHTOA is very useful in this case. Let's try another one. Let's try another one. Something a bit more interesting. Let's go to 2016 March, paper 2, question 8. Let's do that one there. I'm about to give you stuff to do. So after I'm done with this question, I'm going to give you stuff to do. We keep going on and on and on, revising together and all. All right, here we go. I'm ready for the next one. In the diagram below, tangent KT to the circle K is parallel to the chord. So the tangent is parallel to the chord NM. I can see it on the diagram that KT is parallel to NM. NT cuts the circle at L. So cuts the circle at L. Perfect. Then triangle KML. So K, then ML is drawn. I see that. M2, that's 40. MKT, the whole of MKT, which is K1 and K2, are 84. I start my story. Determine with reasons the size of K2. Work with me. Now, if you notice, K2 is from here, the tangent, and touches the chord KL. Who subtends KL at the circumference? It's M2. So M2 is subtended by KL at the circumference. Work with me. That means M2, or rather K2. It means K2 will be equal to 40 degrees. Your reason, Tangent-chord theorem. I'm okay with that. See, the Tangent-chord is always coming through, right? Tangent-chord is always coming through. Never not available. Tangent-chord is always coming through. All right, that's K2. Now I want N1. N1. So there's my N1. I want N1. Now hold on and work with me here. N1 is made by a line from M and a line from L. That's what makes N1. Notice that K1 is also made by a line from M and a line from L. All right. So K1 and N1 are angles in the same segment. All right. So they are angles in the same segment. N1 and K1. Now, when it comes to calculating K1, it's going to be easy. Remember that K1 and K2 from the diagram are equal to 84, but K2, we found it as 40, so K1 becomes 44. Maths, let's do this. Therefore, N1, which is what we're looking for, is equal to K1, is equal to 44. Your reason, angles in the same segment. So the same chord, which is ML, is subtending N1 at the circumference and K1 also at the circumference, right? So this is very important to understand how you can break it down. So you need to be able, and I always emphasize this, fam, look at your diagram. One of the first questions you must ask yourself is, who subtends N1? ML. Does ML subtend anyone else? Yes, it does. It subtends K1 at the circumference, so it's angles in the same segment. I'm ready for 8.13. We're working together. I'm glad that people are understanding, but I want you to be able to hear me out in all circumstances. Also, fam, trust yourself when you're doing Euclidean. Trust yourself when you're doing maths. These things are not difficult at all. It's something that you can do. But I'm taking this out. Gone, gone, going. So remember again, just to reiterate, the angle N1 is made by a line from N and a line from L, and the angle K1 also by a line from M as well as a line from L. But we did find K2 as 40, so K1 is 44. So N1 and K1 are the same. I want T. That's 8.13. I want T. Let's see what's happening there. So let's gather our information and see what's happening. What do I know? You know, what do I know? So this is what I want. I want this guy. I want T. What do I know? What can I do? How can I break this down? All right. I think T and N1 are equal. Ooh, say, really? Why? Why are you saying T and N1 are equal? Really, say? Come on now, my students, help me out. Parallel lines, come on now. Come on now. T and N1 are equal. Say, why? All right, alternate angles. Thank you so much, family members. So T is equal to N1 is equal to 44 because they are alternate angles. I must specify which lines are parallel. So the lines that are parallel are KT parallel to MN. 8.31, done and dusted. Good to go. Right, 8.14. Let's go. Again, guys, please remember that if you have a question, you can always lift up your hand through the platform and I can unmute you. Right, I can always unmute you. Guys, as it starts, it looks a bit easy because that's how I start all my questions anyway. They start easy. So you may look at it like, I got this. Oh, Chuck Norris. Chuck Norris. Hey, I'm fit. Right, let's go for L2. For L2, where's L2? That's L2 right here. L2, I'm ready. L2. T, I'm going for 44. K2, I'm going for 40. I think I'm going to win. I think I'm going to win. Check this out, fam. If you consider this triangle, this one here. Right? So I want to help you out. So it's important to break things down into pieces. 8.1.4. So if I'm on triangle K, L, T. L2 is exterior. outside. L2 is an exterior angle. L2 is actually equal to K2 plus T. The theorem, exterior angle of a triangle. L2, where are you? I'm outside. Who are you equal to? I'm equal to the sum of the two interior opposite angles. So the theorem says the exterior angle of a triangle, L2, is equal to the sum of the two interior angles, 40, 44, 84. That's L2. All right? That's L2. But there's another way of doing it. Just in case you're struggling, you know what you can do? Same triangle, KLT. Notice that you can find L3. You can find L3. So it will be 40 plus 44 plus L3 is equal to 180. Sum of angles in a triangle right there. What do you get for L3? Talk to me. What do you get for L3? But remember, I'm looking for L2. So I want you guys to get involved. What do you get for L3 when you do that? I hear 96. Love it. 96, that's L3. Then finally, you can say L2 plus L3 is 180. Why? Angles on a straight line. Angles on a straight line. I know that L3 is 96. L2, there you are. So you get the same answer like I did. It's 84. Bit longer, but still okay. So L2 from my first one is exterior angle of a triangle, or you can go the whole full cycle from there on. Thank you. I'm ready for L1, which is my last one there. L1, L1, L1. Right. Taking this out. Gone, going. Boom. L1 fam. It's crying on L1 sham. What can I do? What can I do? Follow my lead. I got your back. Now notice something. Still, you can use triangles, ne? This, that. Okay, all right. Say you're onto something. Yep, I am. Work with me. K1, okay, plus M2, okay, plus L1, all right, plus L2, all right, is 180. Sum of angles in a triangle. It's 180. Okay, do I know K1? Yeah, I do. From the previous ones, I think we did K1. We found it as 44. Do I know M2? Yes, it's 40. Do I know L1? No. Do I know L2? Yes. 84. Then 180. Algebra, maths, 12. End of story. All right, fam, we've done that one right there. I want you to be able to come through and pull through on that one. I'm ready. Okay, so I'm going to give you a question to try now, just for like 5 minutes or so. Then I'll come through for you and be able to help you out on that one so that it's easier to work. Try. With maths, you got to keep doing. The more you know, the more you do, the more you know. The less you do, the less you know. All right, fam, going. Azo, try this first. Let me do this with you because I'm not finished this question. Then I'll come through to the one that I want. Somebody says, is K1 not 84? No. K1 and K2 are 84. not K1. No, 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 not at all. Remember, this whole angle is 84. That's why it starts there. It includes K2 and K1. So it's not 84. All right, let me try the next one quickly. I'll do this with you, then let me see what I want to give you next. Okay, sharp, that's fine. And then let's go. In the diagram below, A, B, and DC are chords of a circle. Okay, A, B, and DC. All right, sharp. E is a point on AB such that BCDE is a parallelogram. Oh, beautiful. BCDE is a parallelogram. What do I know about parallelograms? The opposite sides are equal and parallel. Secondly, what do I know about a parallelogram? The opposite angles are equal. So remember these properties, especially on a parallelogram. What do I know? Opposite sides are equal and the opposite angles are also equal. Remember that. DEB is 108. I see you. DAE is 2x plus 40. And then the question says, calculate, giving reasons, the value of x. Sure. Let's start. C is 108. Say. Why are you saying that? Opposite angles of a parallelogram. They're equal. Those are the properties. Opposite angles of a parallelogram. This is how you write the shortcut. Parallelogram. So E, or rather C is 108 because it's opposite to E. All right, sharp. Then what? Hey, man, I want X, man. I think I see a cyclic quad. I think I see a cyclic quad. Which one, say? Which one are you seeing? Don't worry, I'm going to show it to you. A, B, C, D. There you are. I think I see a cyclic quad there. And what else do I know about cyclic quad? The opposite angles are supplementary. In other words, 2x plus 40 plus UC, which is 108, should be equal to 180 degrees because opposite angles of who? Cyclic quad. So the rest is now algebra, abo plus, nabo minus, blah, blah, blah. So here it's going to be 2x plus 148. That's 180. 2x is equal to 32. Divide by 2, 16. That's the value for x. I'm happy about that. Write it down. Next up is questions. So guys, please do remember these properties. Opposite sides of a parallelogram are equal. And then also the opposite angles are equal. These are properties that we learn in grade 9 and 10 and all so that you can pull through. I have a question. Why was 108 added? It's because now if you consider A, B, C, D is a cyclic quad and the opposite angles of a cyclic quad are supplementary. I need to say C is 108. There, 108. So we said C at the top, right at the top in pink. C is 108. All right. I'm ready. Love it. Let's go. Let's get going. Let me try the next one. All right. I'm going to give you this one here. Where is it? There we go. How many minutes? 3. Go. 3. Let's go. All right, let's confirm your answers. Let's confirm your answers just to see if the first part has gone pretty well. I'm ready. Here we go. So the question said, in the diagram, O is the center, very important, of the circle, K, L, M, N, and K, O, and O, M are joined. Chord K, N is produced to S, K2 is 55, and N2 is 100. To begin with, we start. Determine with reasons the size of the following angles right there. So L, I think I see a cyclic quad. I think I do. It should be L, M, N, K. Let me just use lines with colors to make sure that it's clear. And I think L should be 100. Exterior angle of a cyclic quad equal to the interior opposite angle. So then when you think about it, this LN2 is outside and is an exterior angle. It will be equal to L opposite interior angle. That's theorem from grade 11 again. So L is equal to 100. Your reason, exterior angle of a cyclic quad. That's L. I'm good. Let's try O1. O1 may be a bit more interesting. O1 right there, exterior angle of a cyclic quad. Let's try O1. Judging by what I see, I think that O1 is subtended by a line from K and a line from M. So look at subtending. A line from K, there you are, and a line from M. At the same time, ON1 is made also by a line from K and a line from L. Okay, sharp. N1 is 80. Why would I say N1 is 80? It's because angles on a straight line, okay? So if you were to add N1 and N2, you get 80. So this is 80. And then because N1 is subtended by Km at the circumference and O1 also by Km at the center, O1 is 160. Your reason, angle at center is twice angle at circumference. So O1 is 60, 160 rather. So O1 is 160. I want to see if I'm going to get M1 now. So I know this is 160. I know N is 100. So I'm looking for N1. Maybe if you didn't know this, I got your back. Got your back. Now, I have a question before I start. Before I do the 8.3. Is L, M, O, K a cyclic quad, yes or no? If you say yes, you must give me a reason. If you say no, you must give me a reason. Is K, L, is L, M, N, yeah, L, M, O. Now reading the alphabet. All right, is this shape a cyclic quad? Yes or no? All right, no, because you can see one of the points doesn't touch the circumference. It's not. So O is a problem. So it's not a cyclic quad. But nevertheless, it's a quad. Yes, it's not a cyclic quad, but it's a quad. It's got 4 sides. And one thing you need to know about quads is that all the angles in a quad add up to 360. So 100, that's L. 55, that's K2. O1, that's 160. And M1, I don't know. They add up to 360. All the angles in any quad, whether the quad is cyclic or whatever. When you add all the angles at the end of the day, they add up to 360. So sum of angles of a quad. I didn't say it's a cyclic quad, I just say it's a quad. Maths, M1 is 45. I'm good to go. I'm happy about that. M1, 45. Talk to me, family members. Right? Talk to me. You guys are helping each other out. And I love it as we're going ahead. Just try another one. Let's try another one. Try another one quickly on that one. Let me try another one. Taking this out. Gone, gone, going, gone. Boom. Right there. All right. Don't want this one. I want this one. Yes. Try this one. I'll give you 3 minutes, 4 minutes for this. Try this one. Let's go. 2016 KZN. Prelim paper 2. I just want to increase the tempo a bit, try to do a bit more challenging questions. I'm so proud of you. We're all learning. We're all making it happen. Let's go. Perfect. I'm ready. Let's start on this one to see if we're on the right track and we're winning together. So the question starts off this way. In the diagram below, PQ is a chord of circle O. OR is perpendicular to PQ, and OR intersects PQ at T. If the radius of the circle is 13 and PT is 12, calculate the length of PQ. Okay, perfect. So let's discuss a couple of things together and see if we're going to win. So the center is clear. It's O. Then OT happens to be perpendicular to PQ. I can see it on the diagram, so I'm given. Then it's a line drawn from the center of the circle to perpendicular to the chord. According to the theorem, it says if a line is drawn from the center of the circle and is perpendicular to the chord, then that line bisects the chord. So T is midpoint. The reason, line from center perpendicular to chord bisects chord, all right? Then PT is 12, they told me. That means PQ must be 24 centimeters, because it means T is a midpoint. Line from center perpendicular to the chord bisects the chord. So PT is 12, PQ would be 24. This is also 12, by the way, right there. So I think I'm good on that, eh? I want 4 marks now for the next one right there. 4 marks, let's work it out. PR, I want this guy, PR. Right, let's work together and see. Now, I need to think with you right here, because I want to find PR right here. I don't know what TR is either, but I know the angle here at T would be 90 as well. And I know that the radius is 13. So that's fine. I can get OT. I think I can. So if I consider triangle OQT, then 13 squared, which is OQ squared, is equal to 12 squared plus OT squared. Whose theorem am I using? Pythagoras. So I can use Pythagoras theorem to find OT. But remember, guys, I'm looking for what? PR. Okay, I'm okay with that. So at the end of the day, my math says 169, 144 plus OT squared, 25 when you take 144 to the other side. So OT after square rooting is 5. So I now know what OT is 5. By the way, fam, check this out. Notice that OR is also radius. OR is also 13 because it starts from the center to the end of the circle. So OR is 13. So that means if OT is 5, then that means TR would be equal to 8. So here it will end up as 8 because look at it. From O to T and from T to R, I must give you 13, which is the radius. OT, we found it as 5. So TR is now 8. Then finally, we can find my PR. So which triangle am I using now? I'm using, let me bring it this side, triangle PTR. So PR squared is now 12 squared plus 8 squared, which eventually gets to 208. That's PR squared. So PR is 4 root of 13 or if you change it to decimal, 14,42 centimeters right there. That's your answer. And I think I'm okay with all of that. Talk to me. Talk to me. Is OT not 13 divided by 2? No, it's not. It's not. It's not. 13 is not a diameter, it's a radius. All right. Where did the 8 come from? Let me help you. Got your back, guys. Don't worry. And I'm going to give you something. I want to increase the tempo. The last 30 minutes, I'm going to give you crazy stuff. So TR is 8. I need to from there to there. It's 8. Because you know what, guys? Listen. OR is radius. Ne? OR is also 13. So from O all the way to R, it's 13. From O to T, it's 5. That means from T to R would be 8. I need to make it into 13. So that's where it's coming from. And all. So we used a lot of Pythagoras theorem here, and the theorem that says line from center of the circle is perpendicular to the chord bisects the chord. Taking this out, gone, gone, going, gone. Boom. All right, let me up the game a bit. Let me look for something a bit more challenging right there. No. Okay, this one will be okay-ish. So this one is fine. I want you to try this. 2017, Johannesburg. I think I over-prepared for this lesson. I've got so many questions. So many of them, you know. So try this. Try this first. And then when you're done with this part, I need to take you to the other part right there. So it's going to be exciting. Try this. I'll give you 5 minutes on this, on that one. No, let me give you 4 minutes here, then another 3 minutes the other side. Then we go. 2017 Johannesburg subcluster. Go for it. All right, guys, I want to change sides. I want to go to the other one. You may take a screenshot of this if you're still on this part, but I want to shift it up to the next one. So let me give you a bit of a moment to take a screenshot of this while I shift it up to the next part, which is what I also want you guys to do. Another extra 5 minutes, then I come through. All right, I think screenshot done. Should be. Perfect. I'll also take a screenshot and put it in our groups, just in case someone is struggling. Continue with this another 5 minutes. One more minute. One more minute. All right, let's go through it. I'll start with the first part. So you'll mark against yourselves. I'm very proud of the interaction that's happening, the way people are just helping each other out. Thank you so much. In the diagram, O is the center of the circle. PWSR is a cyclic chord. PSWO and OS are drawn. And finally, PW is parallel to OS, and P1 is 36. SOW is my first question. That's what I'm going to start with. So it looks like to me, SOW is this angle here. So my question is, who subtends it? I think it's SW. I need to look at who makes it, who subtends it. It's a line from S and a line from W. But I also note that a line from S and a line from W subtends P1, which is 36. So one guy is at the center. The guy that I'm looking for is at the center. The other one is at the circumference. So it means SOW, it's always the middle letter, SOW, that's the angle, is 72. The reason angle at center is twice angle at circumference. That's SOW. That's 9.11. Let's try 9.12 together. 9.12 W2. W2. So this is already 72. I think W2 will also be 72 because they are alternate angles. So it's alternate angles. And why? Because PW is parallel to OS. Don't forget to put the parallel part of things. So it's very important that you understand that. Good. There you are. I'm good. And then W or S1 plus S2. Let's see, who's that? Oh, okay, sharp. So the wall of S1 plus S2. Let me see if I can make it. So they want the wall of S1 and S2. This is interesting because I think I see a radius, which is OS, and another radius, which is OW. I know that This angle is 72 already. So to let me make our life easy. Say let S1, you don't need to do it, but I'm just showing it to you. Let S1 and S2 be X. So this is now X, S1 and S2, I call it X. And this also becomes X because there are angles opposite equal sides. So S1 and S2 is equal to W1. It's angles opposite equal sides. You can even say equal radii if you want. So that's all good and well. Then I'm looking for X, which is S1 and S2. So X plus X, right? Because this is X, S1, S2. W1 is also the same thing. Plus 72 is equal to 180. The sum of angles in a triangle. The rest is maths now. I think you can see for yourself. So it's going to be 2x. Right there, I think it's 108. So x is 54. So that's what x is. S1, S2 is 54. So nothing too hectic. I just put the x part just to make your life a bit easier, but otherwise it's pretty much the same thing. So it's not too difficult when you think about it. It's always a matter of noticing your situation. R, I think they want R now. So I think there is a cyclic chord. So I think I can get the R pretty clear. W1 is X. So W1, let me write it on the side. So W1 is 54. All right. So from the previous one, it's the same thing like S1 and S2. W2 is 72. We got it in the previous one. Got it in 9.11. So this whole angle will be 72 plus 54. And I'm looking for R. Opposite angles of a cyclic chord. There you are. In other words, look at this. I'm going to say to myself, 54 plus 72 plus R is equal to 180. I'm running out of space. Let me just take this part out so I don't have to strain myself a lot. Okay, just to reiterate it again, I'm giving the idea that W1 is 54, W2 is 72, then W1 plus W2 plus R is 180, opposite angles of cyclic chord. W1, who are you? I'm 54. W2, who are you? I'm 72. Then there's R is equal to 180. So when you do your maths proper, the value of R is 54. Good. Happy about that? That's what you have right there. All right. Yo, guys, I love your comments. I deserve an Oscar. Yeah, boy, I should beg my parents to pay for me for my classes. Definitely, guys, you have no idea. It's huge. The type of stuff that we do in the classes is big, man. And we're passing and we're getting distinctions. All right, so the questions are very important. And I always make sure that I create all these documents proper and good, clean, past exam papers, all of them. And I gather information and I write good notes, really good notes. You've seen that with my handouts that I sent to you. Let's try 9.2 together as a team, as a family. Let's work it out. In the diagram, OP is the diameter of the smaller circle. So OP is the diameter of the smaller circle. O is the center of the larger circle. Okay, O is the center of the larger one. PTW is a chord of the larger circle. I think it's fine. And T lies on the small circle. OT is joined. If OT is 10, so let me just build up. PW, so from here to here, the wall of PW, this whole thing, is 48. Thank you. Then what do they want? Calculate the radius of the smaller circle. Okay. So you know what? If I get OP, which is the diameter of the smaller circle, and divide it by 2, I can get the radius, right? If I get OP right there, which is the diameter of the smaller circle, divided by 2, I can get the radius. But let me think. Let me see what I know and what I can do. All right, so I remember that this is 10. Remember that OPW is 48. Okay, cool. T1 is 90. Yeah. If I consider the small circle, T1 is 90. Your reason? Angles in a semicircle. Yebo. T1 is 90. Angles in a semicircle. That's T1. Okay, sharp. So then what? Because if I find T1, then what? Then I remember, okay, fine. PW is 48. And O is the center of the big circle. So now I'm going to the big circle. Right? So OT is a line drawn from the center of the circle, and it will be perpendicular to the chord PW. So OT is from the center of the circle, and it's perpendicular to the chord PW. I need we agreed that T1 is 90. So therefore, this will be perpendicular. So therefore, we write OT is perpendicular to PW. That means PT is 24. Say, how come? Yeah. Because think about it, fam. Think about it. A line drawn from the center of the circle, perpendicular to the chord, bisects the chord. So T becomes the midpoint of PW. So PT is 24. Even TW is 24. Line from center perpendicular to chord bisects chord. All right. Line from center perpendicular to chord bisects chord. So PT is 24. I know OT is 10. So now let me go to the small circle. So it was a matter of jumping small, big, and looking at how you can relate them. So let me go to the small circle. And now I'm on triangle OPT. Remember, I'm looking for the radius of the small circle. I can find OP now. Pythagoras, OP squared is 10 squared plus 24 squared. And that's the Pythagoras theorem. And then when you want to lock it down nicely, right there, you will then say 10 squared plus 24 squared, that's 676. So OP squared, you can find OP, I think it's going to be 26. Then the radius, because OP is diameter, the radius is 26 divided by 2, which is 13 centimeters. Right there, man. All right. So that's the radius. Remember, OP was diameter, but now we're going to do the radius kind of thing. Yo, beautiful, man. Beautiful. Right there. So people got it. Somebody says, will I be right if I use the cosine rule? Let me see how you would have used it. Yeah, you would. You get the same answer. Cos 90 will be 0, so you get back to the same thing. Why are we dividing? It's because we're looking for the radius, and OP is diameter of the small circle. That's why we divide by 2. All right. So OP squared 676, and I square rooted, ne? To find OP, I square rooted. And so therefore, I got 26 and all. All right, let's try our last one. I think the last one will be more interesting. You guys have been amazing. We're almost to the end of our lesson. It's been great. Again, I emphasize the importance of making sure that you understand, you work hard. Remember, guys, I'm going to be doing revision classes, huge revision classes that we're going to have coming up in June and in May. And they're very cheap. I'm going to also be doing Euclidean geometry. I've got even crazier questions on that one. Oh my word, you guys have no idea, man. I gather stuff and I really put it across quite well. Talk to your parents and take it up from there. I'm giving the idea again of dividing because I keep getting the question, why am I dividing? OP is the diameter. You are looking for radius. Radius is half the diameter. So if the diameter is 26, the radius is half of it. And all that. So that's very important. So radius, yeah, radius is half the diameter. That's pretty much what radius is. Half the diameter. If you have calculated the diameter, then yes. All right, taking this out, going, boom, right there. All right, let me give you something that will, okay, let me just give you this. Try this. Let's see if you're going to win. Yeah, try this. Let's see if you're going to win. Then the rest, I put so many, guys, look at it. I'd over-prepared. All right, so let's do this. It's fine. So 2011, paper 3. Did you know that Mez had paper 3 before then? They had huge paper 3. It was crazy, man. So I want you to try this one here and let's see if you're going to win. Good luck. And I'll give you about 5 minutes or so. We're almost to the end of our lesson. And I really am grateful. I really honestly love people that say thank you. I really think if someone does something for you for free and that someone is taking their time and their effort, in Africa, we say thank you so much because it really means a lot, you know, really means a lot. Okay, let's do this one as our last one. Let's go out with the bang. Let me give you 3 minutes. Go for it. All right. I think we should be okay. Hoping that people are okay. Love the messages that you guys are writing. Want to make me so emotional. I will be fit. You want me to cry? Thank you. I love you so much. I love you, and I don't even know you. Can you imagine? I don't even know how you guys look. I really appreciate you. And I really want to have you guys pass. I will do my best. That's why my lessons are cheap, affordable, because I want you to pass. I want you to have a better life. I want you to have better decisions. I want you to change the life of your family, change your own life, shift the whole paradigm of your history, coming from maybe not so well-off families, but going to varsities next year when we finish our matric, or the other year when we finish it, you know, making a difference in our lives. You are going far in this life. I tell you that. You're going very far. I need you to keep believing in yourself. I need you to keep telling yourself that you can make it. Put the effort, work extremely hard. Don't give up on yourself. And also be grateful to the parents that you guys have. I hope you guys, you know that they're trying their best to make sure that you have food, roof over your head, clothes on your back, money in the pocket, a phone, a decent Wi-Fi network, data. They're trying. The best you can do is to make sure that you give them good results. They're not asking you to buy food. They're not asking you to buy clothes. They're just asking you to pass. I am so grateful for all these comments, and it makes me so emotional to know that I've got so many people that really love and appreciate me, and I truly love you too. I do, and thank you for the blessings that you're pronouncing upon my life, upon the life of my family, and everything. Nama Bentley, nama horses, nama Porsche. Yazi Nina, I'm Shem. All right, let's do this last one and slide off to a great night. We've had a good time today. I really enjoyed it myself. Let me just run through this question quickly, and then we go for it. O is the center of the circle AB produced, DO produced to meet at C. BC, so there's BC there, is equal to OA. That's fine. Let me just put my two strokes here. And then you've got OACO as 22. So that's fine. Calculate with reasons, AOD. So AOD. So the one, this one here. Let me call it X. AOD. So let me say, let AOD. It's always easier to work with smaller letters as X. All right, we're good. I'm fine. Let's see if I can work out some magic in all of that. The first thing that I can see is that OA is also like OB. So OA is OB because they are radii. Remember, they come from the center. So that means, therefore, OA is OB and OA is BC. So this guy is equal to that guy, and this guy is equal to that. So everyone is equal now because they're all equal to each other. So if this is equal to that, then this is equal to that, then it means OB will be equal to BC. All right, so I'll just write and say OA is equal to BC. We're given. So what? It means, therefore, OB will be equal to BC. If that's the case, then notice that O1 will become 22 because triangle OBC. So O1 becomes 22 degrees. Why? Because it's opposite angles, or angles opposite equal sides. So I'm okay with that. So O1 is 22. All right. I can find B2 because remember, I'm looking for this guy, by the way. I'm looking for this guy. So I think I can find B2. So if I consider triangle OBC again, B2 is outside. So it's equal to the two interior opposite, 22 plus 22. So it's exterior angle of triangle. Or if you're struggling with it, you know what you can do, ne? You can always find B1. I need to 22 plus B1 is 180. You can get B1, then B1 plus B2 is 180 angles on a straight line. So about to B2 is going to be 44 right there. That's 44, that's B2. But if I consider triangle OBC, look at it, B2 and A should be equal because they are angles opposite equal radii. Look at it. So B2 is equal to A is equal to 44. These are angles opposite equal sides again. So it's just a matter of playing around with all the situations, equal sides. So this is also 44. But I'm looking for X, ne? Looking for X. I can find O2. I think I can, because O2 plus 44 plus 44 should give me 180. These are sum of angles in a triangle. So at the end of the day, the O2 is going to be what? If you could subtract that, so it's 180 minus 88, I think it's going to be 92. So I'm good to go. So O2 is 92. Then finally, I think I'm going to get my X. So if I consider that this is now 92, so X plus 92 plus 22 is equal to 180. Your reason, angles on straight line, I'll just write SL for now. The rest is maths. X, which is AOD. When you do your maths, it will be 66. Oh, lovely, 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 beautiful, beautiful. Okay. Oh, you guys are wonderful. All right, so let me know if there's a struggle on this one, which is our last question. And all, just let me know. Just let me know. Hard work, hard work. I love what one of you guys has said. Good luck, you will make it to all your exams. But remember, don't get comfortable in believing in luck. I agree. Always believe in hard work and trust yourself in the process. You will surely nail it. All right, guys. So this has been our last question for what we've done today. I just want to thank you so much again for coming through. Let me just give one announcement, then we can call it a day. So just bear with me for like a minute or so. And as I get ready to give one announcement, you can take a screenshot of this before I take it out so that you are ready and all daring for everything right there. Okay, let me take this out, gone. And that out as well. The screen has been closed. Let me go back. Just a reminder of some very important things that are coming up in the next coming. All right, yeah, you can still, okay, I thought I was gone. All right, there. So this is the important part here. Remember, I'm doing the revision classes, guys. If you thought today was fire, you have no idea what I'm going to do when I start with the revision classes. I'm creating top-notch questions, top-notch, proper stuff. So these are the days and the dates. I'll send this on the group as well. For the revision classes, 5 hours with Mr. X. You just did 2. Imagine 5 with me, what we can do together. So these are the classes. You pick whatever you want. If you want to do all of them, 100 rands for each of them for a 5-hour session. These are the times and everything I've put across so that you guys can be able to work it out. The registration, or rather the bookings of it, are starting on Wednesday. So just let me know if you're interested in that. Then we can do that on Wednesday. Guys, I've got limited space. As you can see today, there was a lot of people. So I've got limited space. I can't take everyone, so I'll limit. So first come, first serve. Someone has already paid. I was like, okay, sharp. That means you've already guaranteed your place. That's fine. I'll take it up from there. But otherwise, Wednesday will be the day when I'm a bit free enough to check the bookings and all. Talk to your parents, work it out. Let's take it up from there. I will do some free lesson as well. Don't always do them, but I try to do one every month so that people can get to learn, can get to know. I love you so much. I want the best for you always. May God bless you. May God keep you. May God's face shine upon you. May you be strong and work extremely hard. Don't forget that also, I do these weekly classes every single week for my online classes, 7 to 9. This is what I'm doing the whole of May, 50 Rand per class, but you pay for the minimum of 2. So look at them, choose my ketela, and take up from what you want. Thank you so much, family members. I appreciate you. So let's just do this. Let me just stop the recording now. Then what I usually do is I give my students a chance to say something towards the end. So let me stop the recording. I will also upload this on YouTube.